All right, everybody, I wanted to make sure that we had solutions to the practice exam, so I'm going to go ahead and get started. We have two free response questions, and I want to begin with this one. And even before I begin, I'm going to actually do this in the order or the preference that I do when I'm solving AP questions sort of in real life. So first, I try to skim. I notice there's two blocks. I notice there's a clear indication that I need to draw a free body diagram. And so what I'm going to do here is I'm going to skim through this first paragraph just to see if there's anything that I need to know. So I read the word coefficient of kinetic friction, and I know that I have a mu kinetic right here. I'm told that friction applies to in between the blocks, and I'm told here that there is no friction between the slab and the surface. So now I can go ahead and set up a free body diagram. The other thing that I'm told is that this block is sliding to the right. And what that means is that guarantees that friction on the block from the slab would point to the left in order to slow it down. So then we have a normal on the block due to the slab. We have a weight on the block due to the earth. This 4 meters per second, I want to be really clear on something. This V naught equals 4 meters per second. I want to be very clear on the fact that that is absolutely not a force. And it doesn't get included in the free body diagram. Next, we have the slab. There's a normal on the slab due to the earth pushing up on it, or the floor. Excuse me. There's the weight of the slab due to the earth. There is a normal force on the slab due to the block. That's actually the third law partner here. And similarly, the block grabs the slab a little bit and moves it to the right, and it does so by means of the third law partner friction force with this force right here. Awesome. So now what we're going to do is we're going to solve a couple of things just to keep this going. So we want to calculate V final, so we'll go ahead and do that now. And in order for us to calculate V final, we're told, so we want to calculate V final, which is, what do they even mean? So we read and we realize that there is a point where the block and the slab actually reach the same speed. And we're going to actually figure out what that final speed is. So the forces involved. Well, I have the friction on the block due to the slab causes the block to accelerate. Actually causes the block to accelerate. So this is mass of the block times its acceleration. Now let's be clear. Friction is mu kinetic times normal. So I'm going to do a little substitution here. I just want to remind you that friction is mu times n, and since the normal force balances the weight, we're going to say that mu kinetic mass of the block times g equals mass of the block times its acceleration. So this cancels, and so that's the acceleration we have on the block. And just to be clear here, if we wanted to write down the velocity equation based on the acceleration, the velocity of the block is going to equal v naught, its initial speed, minus its acceleration times time, which in this case is going to be mu kinetic, times g times t. So just to kind of remind you, that's the acceleration. Now for the slab, let's look at its acceleration. We're going to have the friction on the slab due to the block equals the mass of the slab times the acceleration of the slab. So I'm going to actually just write a little label here. This is acceleration of the block, acceleration of the block, acceleration of the block. And let's be careful. The friction on the slab due to the block is the third law partner force here. So this is going to be mu kinetic times mass of the block times g equals mass of the slab times its acceleration. So when we actually get the acceleration of the slab is going to be mb divided by ms times mu kinetic times g. So its equation, the velocity of the slab, equals mu kinetic times mass block over mass slab times g times t. And so what we're going to end up doing is actually figuring out when does v of the block equal v of the slab, and we'll do that by setting them equal. Okay, so I'm just going to give you a procedure here, and I actually kind of want you to do this. Number one, what I'm going to ask you to do is set v block equal to v slab. 2, solve for t. And when you do that, you're going to get that t equals mass of the slab times v naught over mass of the slab plus mass of the block over mu g. And then when you substitute that, you're going to end up getting that the V final is mass of the block times V naught over ms plus mb. And if you're plugging in numbers, you're going to end up getting 0.57 meters per second. So all of this is part B. Now for part C, you're going to get that the common V is 0.57 meters per second. So what we can actually do, we've got the acceleration of the slab as mb over ms times mu k times g. And when we plug in those numbers, we're actually going to end up getting that the acceleration of the slab is 0.33 meters per second. So using those two facts, we can basically say that the distance the slab travels, v squared, equals v naught squared plus 2a delta x. So we're going to end up getting 0.57 squared equals 2 times 0.33 times delta x. And when we get delta x, that's actually going to simplify to about 0.48, 0.49 meters. Okay. And then for the last part, when we want the work done by friction, I gave you a hint. And when you actually apply that hint, you should get 0.49 joules. And so I will go ahead and actually let you finish that up on your own. So that is free response question number 1.